Welcome to A&E Training and Technical Solutions presentation on electrical safety. In Section 1, we will look at energy flow and barriers. In Section 2, the effects of electrical induction. In Section 3, the dangers of step and touch potential. In Section 4, the effects of electricity on the human body. In Section 5, electrical shock and arc flash hazards. Section 6, electrical safety training for the qualified electrical worker. Section 7, personal protective equipment. Section 8, safe work procedures. And in Section 9, we will look at corded electrical equipment, extension cords, ground fault circuit interrupters, and circuit protection devices. On behalf of A&E Training and Technical Solutions, thank you for purchasing this training program. Let's begin our program on electrical safety, energy flow, and barriers. This section will deal with how we control the flow of electrical energy and also how we use barriers to control that flow. Let's first look at the flow of electrical energy. To control the flow of electricity safely, it is necessary to limit the flow of electrons to the conductors of the circuit. You might relate this to cars traveling down a highway. The flow of traffic is controlled by the use of barriers, just as electron flow is controlled by the use of insulation around the conductors. When this flow is controlled, electricity performs its work safely and efficiently. But when the flow of electricity gets out of control, it can be a very destructive and dangerous force. How does electricity get out of control? It is usually a result of insulation breakdown or deterioration. Insulation of electrical equipment comes in many forms. It can be as simple as an air gap between conductors in an outdoor station. In this case, the air itself acts as an insulator. One of the most common forms of insulation is found on low-voltage cables. These cables are usually insulated with a PVC or vinyl coating. Mineral oil is also used as an insulating medium in transformers and oil circuit breakers. The oil acts as an insulating medium between the live parts and the grounded tank. Insulation deteriorates as a result of contaminants entering the insulation medium. Contaminants include moisture, dust, dirt, carbon, and environmental pollutants, all of which can lead to insulation failure. Other factors that can cause undesired energy flow are overvoltages caused by lightning strikes, voltage surges caused by switching operations, and human error or a breakdown in a barrier. When you are working in an electrical environment, the first thing you must do is plan the job you are about to do. This includes identifying the hazards using the safety basics. You must first identify all hazards in your working environment. Then, if practical, you must eliminate them. If you cannot eliminate the hazards, you must take action to control the hazards. You must also be able to protect against injury if energy flows get out of control. This may include wearing safety glasses, rubber gloves, and a hard hat. Finally, you must minimize the severity of injury if an accident occurs. This would mean having a rescue plan in effect, or first aid materials close by. During the course of your work, conditions can change. If changes do occur, you must stop and reevaluate the hazards before continuing to work. This is very important, so new hazards are not overlooked. In order to control hazards, we use barriers. A barrier can be defined as anything that effectively keeps you separated from the hazard. A barrier can be something visible, such as a rubber blanket used for covering up live equipment. It could also be mesh netting or fencing placed around equipment to keep workers away. These are examples of physical barriers. Physical barriers are placed between the worker and the hazard to provide a layer of protection. The wearing of personal protective equipment such as hard hat, rubber gloves, safety glasses, and safety boots are all forms of a barrier that can be found on a worker. Barriers can also be non-physical. These barriers include company policies and procedures, work protection code, Occupational Health and Safety Act and codes, Electrical Safety Code, CSA Z462, safety training, and other written documents. Although these are non-physical barriers, the correct application will effectively keep you separated from the hazards. Barriers provide the protection. Therefore, the more barriers you have in place, the lower the risk of injury to personnel. This is the basis for the multi-barrier principle. If the first barrier breaks down, you still have the next barrier for protection. To be effective, a barrier must be used properly. This begins with training in the safe installation and removal of different barriers. You must know when, where, and at what voltage class different barriers should be used. Remember, the misuse or wrong positioning of a barrier could in itself create a life-threatening hazard. When a piece of electrical equipment is switched out of service, it is considered to be isolated. This means that the equipment has been separated from all sources of electrical energy. Where worker protection depends on the isolation of a circuit or circuit part, the equipment shall be de-energized prior to work being started. Before work begins on a piece of equipment, you must apply portable temporary grounds. When the grounds have been applied, the equipment is considered to be de-energized or drained of electrical charge. De-energizing also includes minimizing, or where practicable, eliminating mechanical hazards. These hazards could include pressurized systems, charged springs, high temperatures, and many others. Grounding is simply the connection of an isolated object to earth or ground potential by way of a metallic conductor. Grounding accomplishes three things: provides positive proof of isolation, provides a means of draining away any induced charges, and ensures that the equipment remains de-energized for the duration of the work. Bonding is another term which is sometimes confused with grounding. Bonding is the connection of two or more elements of an electrical system to keep them at the same potential. In this example, the scaffold, the truck, and the isolated bus are all bonded together at the ground stirrup. The bonded elements are then connected to ground via the station ground grid. The principle of bonding is to provide a low-resistance parallel path around a person's body to ground. This is the conclusion of this section of our electrical safety program. Please take some time now to read over this section in the student manual, answer the review questions, and then return to the program.